After you've gone through the normalization process, you're going to want to use that information to create a database of your own, using all of the tables and field names that you've created. And there are multiple ways to approach this. You could, for example, use the create command, which we've already talked about, and create all of the tables individually, one by one. There is also a data modeler tool within MySQL, or within MySQL Workbench at least. To give you an example of what the tool looks like, we're just going to use the restaurants table, or the restaurant database as an example. So what we're going to do is, from database, we're going to click reverse engineer. And this is going to ask us for a lot of information so that MySQL Workbench can actually process the information within our database and create a model for us. So by default, this may not be selected, it may be blank. But if you select the actual database that we've been using and then click next, we can basically just click next, ticking restaurant. And then it's just a matter of clicking next until we get to the end of the process. And what this does is it will create a table representing each of the individual tables within our database, which we can then manipulate ourselves. And you can see here we also have the view that we created called staff table. Now on its own, this is a more visual way of understanding how your database interacts with itself and how all of the different components look. But we can use it for more than that. We can use it to actually map across which primary keys interact with which other tables and how they interact. So for example, we would want our staff table, particularly the department number column, to be connected to the department table, because that's how it is supposed to be connected in our database. But the relationship isn't actually populated here, because when we've created our table, we've not actually declared the department number in the staff table to be a foreign key. And so what we can do is, on the left, we've got these icons, and we're going to click on the 1:n button, which represents one-to-many. And then we're going to click on the staff table and then the department table. And as you can see, this has added a new column in here into our table for us called department number. Now this should actually replace the department number that's already in our table. So if you double click, you'll get this option. And what we can do is delete this department number that's already in our database and rename this to department number. You can see now that we've got this relationship actually represented properly in our database. So many members of staff can be in one department, and one department can have many members of staff. And if you actually highlight the tables, it will show you the actual individual columns which are related. Same with if you highlight the actual relationship as well. Now we also have the staff number and the staff number here in the staff training table. But you can see that here the staff number is an integer of 11, while the staff number here is an integer of 4. And so you can use this to actually make sure that the staff number is going to be consistent throughout your entire database. And so what we can do is, in the staff training, we can double click this and change this to integer 4. And we can add another one-to-many relationship. And as you can see at the bottom, it says select the table to receive the foreign key. Well, that's going to be the staff training table. And then it changes to say staff training selected. Please select the reference table, which is the staff table. So this is how you know that the staff number is going to be inserted correctly. But as you can see again, we've got staff number instead of the original staff number. So what we can do now is just delete this and change this to staff number. and we can even change the order back to how it was. And we can also do the same again for the training table. So if we select one for many, the foreign key table, which is the staff training table, and then the reference table, which is the training table. And again, it's done the same again. It's added a new column in here, which is going to delete the one that was already in there. And we're going to rename this one. So as you can see, the customer table and the salary range table and the view that we created don't actually have any direct connections to any of the other tables. But some of the tables do have connections to multiple tables, like this staff training table. Now if you're creating a database from scratch and you're using this tool, you can create new tables from scratch entirely, which is just a matter of pressing this button, the new table button, and then dragging the actual table onto your diagram. And if you double click this, it will create a new section here, so you could add new columns. And you can select whether things are going to be primary keys, whether they're going to be not null, whether they're going to be unique. And a lot of this information you'll be able to gather from the normalization exercise that you've already done. It would simply be a matter of adding more columns for the specific table. Now there are a lot of other options as well. If you double click on the relationships, there are different ways that you can configure these. You can specify details regarding to the foreign key and the relationship. And if you look further at the tables, we also have indexes, foreign keys, triggers, partitioning, options, inserts and privileges. So you can manage all of this through this interface, but you won't be able to actually manipulate the data within the tables from here. If you're creating a new database from scratch using this method, when you're finished with the actual configuration of your tables, you would then click on Database and Forward Engineer. And this will give you a dialog box almost identical to the one we used to reverse engineer our current setup. And again, make sure that the stored connection is going to be to the server that you are going to be using with the correct username. And obviously it's just a matter of clicking through the actual options until you've actually ensured that the configuration is all exactly how you want it. There's not much to do as far as ticking different boxes is concerned. Most of the pre-configured setup will be as you want it. Then it will give you this example script which it's going to run. So this is all of the actual information that it will use to create the tables. So here's the create command for the restaurant customer table. Here's the create command for the department table, and so on. As you can see, none of the actual data is stored in this, so if you do click execute after the next button is clicked, you will lose all of the data within your current database. And so you can see that it's basically set up, but it hasn't committed the progress yet. If you go backwards and click cancel, if you then go across to your actual database and select all of the data, it will still be there. If you didn't click back and cancel and you actually committed to the change, all of this would have been wiped. If you remember back to the transactional session that we did, it's not until you actually click the commit button that all of the changes are saved. So you can get pretty far along the path before changing your mind. Now of course if you want to, you can save all of this, but because there's nothing that we've actually changed other than the relationships which already work in our case, I'm just going to cancel out of this. But obviously if you're creating a database of your own, you may want to keep all of that just so that you can understand the relationships between different tables in the future.